Hi, Dr. Ward here, and today we're going to talk about dimensional analysis problems involving cubed or squared units, which are essentially the same type of problem with just one more or less step depending on whether it's a cubed or a squared unit. So in the previous videos we looked at multi-step problems, we looked at converting units that have units on the top and the bottom, sort of derived units, and simple 1 to 2 step, as well as the fundamental concepts behind dimensional analysis. So if anything that I just said doesn't ring a bell for you, you can certainly go back and watch those earlier videos. In the next video after this, we'll just look at a whole bunch of dimensional analysis problems that involve all the different types of dimensional analysis that we've covered in this video series. So many times in science we're looking at things like area, volume, and those involve squared and cubed units, and we want to convert from one unit to the other. So we can do that using dimensional analysis, but you have to remember where these squared and cubed units come from. How do we end up with a squared unit or a cubed unit? Let's just take a look at a quick example. Let's say we have a square that is 5 centimeters by 4 centimeters. Okay, that would be a square, it would be a rectangle. So to find the area, remember that it would be 5 centimeters times 4 centimeters, which would be 20 centimeters when we multiply the 5 times the 4, and then the centimeters times the centimeters is centimeters squared. We write it that way. But what I want you to remember is that what centimeters squared really means is centimeters times centimeters. Okay? That's how we're going to solve these problems in dimensional analysis, by remembering that you can break down the squared and cubed units into individual sets of centimeters or inches or whatever that unit might be. So now, for example, if we wanted to take this and then have that be a cube that was 5 by 4 by 5 centimeters, well, we'd take our answer here, which was 20 centimeters squared, and then we'd multiply that by the height, or sorry, that would be the depth, which I have is 5 centimeters, and we get 100 centimeters squared times centimeters, which is centimeters cubed, or again 100 centimeters. Okay, so that's how we get squared and cubed units, and it's just helpful to break that down because when we do the conversions, we're going to use that to our advantage. So now let's take a look at a conversion using dimensional analysis that involves a cubed unit. All right, so let's take a look at an example. Let's go back to our cube, since volume is certainly something that we'll be working with all the time. And let's say that we know this cube has a volume of 3 cubic inches. We want to know, what is that in cubic centimeters of volume? Now certainly you could find a conversion factor somewhere online, I'm sure, that converts cubic inches to cubic centimeters directly, and then you multiply by 3 and you'd be done. But we're going to do this using dimensional analysis. So what we want to remember, again, is that 3 cubic inches is 3 inches times inches times inches, inches cubed. And we're going to convert that to centimeters times centimeters times centimeters, which is centimeters cubed. So we need a conversion from inches to centimeters, and then we're going to do that 3 times. So 1 inch equals 2.54 centimeters. That's the only conversion we need, because we're just converting inches. And that's the only conversion we need because we're converting inches to centimeters. We're just doing it 3 times. So let's set this up so we can see what it looks like. So 3 inch cubic inches times, we need to cancel out all 3 of these iterations of inches. So we're going to do 1 inch, 2.54 centimeters. 1 inch, 2.54 centimeters, because we need to cancel this unit 3 times because it's cubed inches. Each time we do that, we need to multiply by a conversion factor that has inches and centimeters because we want our answer to be in cubic centimeters. So we've got to get rid of the inches. So this inch goes here, this one here, this one here. So I canceled out the cubic inches, and then I multiply 3 times 2.54 times 2.54 times 2.54, and centimeters times centimeters times centimeters. So I'm just going to bring this up here to save a little bit of room. What we end up with is 49 centimeters, 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 which is 49 cubic centimeters. Okay, centimeters cubed is centimeters times centimeters. So the math is the same. This is essentially a multi-step dimensional analysis problem. It's just that you have to remember that these cubed units, if it was squared units, we would just do it one less time, because it would be centimeters times centimeters, or centimeters squared, inches times inches, or inches squared. So the math and the setup is all the same. Keep track of your numerator and denominator if you need to add the 1 there. And make sure you have as many conversions for each unit as you have either squared or cubed. If it's squared, you do it twice. If it's cubed, you do it 3 times. Theoretically, you could do it 4 times if it was to the 4th power, if you were doing that dimension, 4th dimensional problem. So that's it. Cubed and squared units involve converting a unit multiple times to cancel it out. We've talked about other types of multi-step problems. We've talked about canceling out units on the tops and the bottoms. We've done simple 1 and 2 step problems and the fundamental concepts that underlie all of these types of problems. The last video will just be several worked out examples of all the different things we've talked about mixed together in different combinations. And if you're struggling with any of this, go back to the beginning. You can watch these videos all again. Thanks.